Okay, so we're talking about section 3.7, implicit differentiation today. And when we do implicit differentiation, this is when we have more complex problems where it's not just plain old y equals. But let's think about this first. If we have y equals, so let's think about this. When we had problems like y equals 5x cubed, when we took the derivative of y, we said dy over dx. It's the derivative of y with respect to x. And that would equal 15x squared. Think about this. This is the derivative with respect to x. So we could think of that as the derivative of x with respect to x, dx dx. Well, hopefully you all realize that that would cancel, and that's why we don't ever write anything like dx over dx. So when we have the derivative, every time we took the derivative of y, we wrote dy dx, or y prime, which means the same thing. Well, that's where we're headed today. We're going to look at problems like problem 1, where it's more complicated. There's more than just y equals something. So now, if we look at problem number 1, it says find dy dx if y squared equals x. So this is a lot more complicated. It's not just plain y equals. Well, just like we take the derivative of x squared and we get 2x, when we take the derivative of y's, we follow the same rules. Just at the end, because it's the derivative with respect to x, the derivative of y squared is going to be 2y, but then we need to take the derivative of y with respect to x, so it's dy dx. So the derivative of y squared is 2y dy dx equals the derivative of x is 1. Now remember, our goal is to find the derivative dy dx. So we need to get dy dx by itself. Well, we would divide by 2y. So in this problem, dy dx equals 1 over 2y. Problem 2. Find dy dx if 2y equals x squared plus sine of y. Notice here we have two y values. So the derivative of 2y would be 2 dy dx. Anytime we take the derivative of a y, we need to follow it with dy dx. The derivative of x squared is 2x plus the derivative of sine of y. Think of the chain rule. The derivative of sine is cosine. Leave the inside alone. The derivative of y is dy dx. Now, how are we going to solve for dy dx? That's our goal. We want to get dy dx equals. So the first thing we're going to do is bring all of our dy dx terms over to the left. So we have 2 dy dx minus cosine of y dy dx equals 2x. Now we use our algebra skills and we're going to factor out dy dx. So we're going to have 2 minus the cosine of y times dy dx equals 2x. We factored out a dy dx out of both of those terms. Now this is multiplication, the quantity times dy dx, so we divide by the quantity on both sides. So now we have dy dx equals 2x over 2 minus the cosine of y. And let me just highlight here that I've seen this already this year, that people want to cancel these 2's off. But remember, we can't do that. This right here is a quantity. It's married. It's stuck together. You can't cancel anything out. Problem 3, find dy dx if 2y equals x squared times sine of y. Did you hear that? Times. Right here we have a product rule that we're going to need to use. So again, we're following all of these rules. If 2y equals x squared times sine of y, the derivative of 2y is 2 dy dx equals derivative of x squared times sine of y, we need the product rule. 1 d2. The derivative of sine of y is cosine of y dy dx plus 2 d1, so times 2x. Now again, our job is to find dy dx, so we want to collect our dy dx terms onto the left side. So 2 dy dx minus x squared cosine of y dy dx equals, I'm going to clean that up, 2x sine of y. I'll factor out my dy dx. So I factored out my dy dx. Now I'm going to divide by that quantity. So now I have dy dx equals 2x sine of y, all divided by 2 minus x squared cosine of y. And again, don't make that mistake that we can cancel those 2's off. That's a quantity. We cannot change that. Problem 4, part of your homework to try. Problem 5. You need to try this for homework. Problem 6 says find the tangent and normal line to the ellipse at -1, 2 if x squared minus x times y plus y squared equals 10. Do you hear that times sign again? So right here at x, y, we have to use the product rule again. Okay, so we want to find the tangent and the normal lines. And remember, we need a point, which we have, and we need a slope. So to find the slope of the tangent line, we need the derivative. So now we're taking the derivative of this function. The derivative of x squared, 2x, minus the derivative of x times y. Think of that as negative x times y. We need the product rule. 1 d2 plus 2 d1 plus the derivative of y squared, 2y dy dx equals the derivative of 10, 0. So I'm going to keep my dy dx's on this side. I'm also going to factor out. So I have negative x plus 2y times dy dx equals negative 2x plus y. Now I'll divide. So when I get my derivative, I have dy dx equals negative 2x plus y divided by negative x plus 2y. There's our derivative. So we want to find first the equation of the tangent line. And remember, for any kind of line, we need a point, which they gave us, and we need a slope. So the slope of the tangent, we use the derivative. Well, we have to plug in x and y. So we're going to have negative 2 times negative 1 plus 2 over negative 1, negative 1, plus 2 times 2. So we get 2 plus 2, which is 4, over 1 plus 4, which is 5. So our slope is 4/5. Now we write the equation of the line. Y minus 2 equals 4/5 times the quantity x plus 1. Distribute and clean up, and we get y equals 4/5 x plus 2 and 4/5. The normal line, remember, for the normal line we need a point and a slope, which we were given the point, and our slope of the normal line, remember, is opposite reciprocal. So the opposite reciprocal of 4/5 is negative 5/4. So we get y minus 2 equals negative 5/4 times x plus 1. So we get y equals negative 5/4 x plus 3/4, 4.75. So we found the tangent line and the normal line. We can also find second and higher order derivatives using implicit differentiation. So in order to do this, we want to find the second derivative of 2x cubed minus 3y squared equals 8. Again, before we can find the second derivative, we need to find the first derivative. So we would have 6x squared minus 6y dy over dx equals, the derivative of 8 is 0. Again, we're trying to find the first derivative, so we have negative 6y dy dx equals 6 negative 6x squared. Then we'll divide by negative 6y. So dy dx equals negative 6x squared over negative 6y. So dy dx equals x squared over y. Okay, we're supposed to find the second derivative. So in order to do that, we take the derivative of the first derivative. Let's think about something first of all. Do you remember that d over dx means find the derivative? So if we're finding the derivative of dy dx, can you see that the notation is going to be d squared y over dx squared? The derivative of the derivative is d squared y over dx squared. D squared dx squared. So now I'm finding the second derivative, so d squared y over dx squared will be quotient rule. Low d high minus high d low. All divided by low squared. Interesting. How in the world do you think we're going to clean this up? Think back to your algebra skills. In this problem, we have a dy dx. We know what dy dx equals. We're going to take our algebra 2 skills, our algebra 1 skills really, we're going to substitute that value back up here for dy dx. So now we have 2xy minus x squared, and in replacing dy dx, I'm going to put x squared over y, all divided by y squared. So that gives me 2xy minus x to the 4th over y, all over y squared. Again, now it comes down to doing some more algebra work. We have a complex fraction here. So what I'm going to do is multiply by y over y, this denominator. Remember, this is a quantity, so I'm going to be distributing this y. So this is going to give me 2xy squared. When I distribute the y here, I'm going to get minus x to the 4th, all over y cubed. That is my second derivative. There is my second derivative. So we had to take the first derivative and substitute it into the second derivative and then do our wonderful algebra work to get that answer.
Which Davis left there in 2000? Larry Coco.
Okay, now this is showing us the power rule for rational powers of x. Well, that rational powers are just rational numbers, which are fractions. And we've done this already. So problem 8, problem 9, and problem 10, you are going to try at home. That's part of your lesson check for tonight. Problem 11, try it as well. Finally, I know I'm overloading you, but this is your homework for the weekend. Problem 12, try that as well tonight. So these assignments, these problems that I ask you to try are due on Monday. When you are finished doing these problems, please go complete the lesson check. And I'd also like you to, once you submit your answers, go in and check out the answers of your classmates and see if you can come up with any mistakes that might have been made. And also, if you have any questions, please make sure you're jotting them down as we go.